continue this discussion. The author likes to use our in everything, our sustainability challenges, our processes of change. So it's a good thing that we're all in this together now, but we should remember historical responsibilities as well. There is a wide range of processes that are continuously changing our complex world, some of them largely independent of human activity, while most of them are at least partly determined by what we do on this earth. I focus the following sections on presenting a number of the most influential processes of change in terms of impact on risk and resilience, which is our focus for sustainability. There are environmental degradation, climate change, demographic and socio-economic processes, globalization, increasing complexity, and changing antagonistic threats. I have, in other words, deliberately left out plate tectonics and other geological and hydrological processes that, although having a great impact on our planet over time, are comparatively stable on human timescales. The processes of change that I do include are full of uncertainty and need to be incorporated in any serious attempt to manage risk for sustainable development. So sustainable development is the focus. Risk is one of the major issues to tackle. So there are issues like demographic and socio-economic processes, complexity, globalization, and of course we looked at climate change already. We are living, of course, in a very complicated system, Earth system as we call it. So we have the natural system, the geosphere and the biosphere, so forced by sun on a daily basis, seasonal basis, as well as on orbital time scales, but we will not worry about the longer time scales. And volcanoes we already looked at. The Earth system has the geosphere and the biosphere, as I just said, and there are plenty of internal feedbacks which amount to giving us internal variability. In other words, even if we were not doing anything, climate always changes, as it has done throughout Earth's history. Ice ages, global snowball episodes, snowball Earth episodes, deglacial times. Plate tectonics, of course, has been a part of it as well. And even on shorter time scales, you have feedbacks, winds carrying moisture and creating rain, tornadoes, hurricanes, cyclones, and so on and so forth. And then human beings have now become part of the forcing, as is implied. When you change the net energy balance at the top of the atmosphere in terms of incoming solar radiation and outgoing thermal radiation, you are called a forcing, and human beings are removing fossil fuels from under the earth, from below the surface, which would not be directly exposed to the climate system unless we take it out and burn it. And of course there are natural oozes and so on, but we have now become a forcing in this sense, and we have our energy systems, knowledge, science, technology, institutions, political economies, human populations with cultures, values and beliefs, and production and consumption, and of course resource extraction and direct impacts, as well as greenhouse gases and other indirect impacts through pollutants and land use change and so on and so forth. So we are also worried about inequality and poverty, justice and so on. When we want to worry about sustainable development, it cannot be sustainable unless everybody is carried along in the system, right? So it is a complex system, and when you have complex systems, you have what are called emergent solutions you don't expect. It's not a, you may have heard of the word convergent. When you solve fluid mechanics problems in the lab setting or even around an aircraft, you often have what are called convergent system. There is numerical convergence and then statistical equilibrium, real equilibrium, and mathematical equilibrium, and so on and so forth. But the Earth system is an open system to space, getting energy in and throwing energy back out, and we are removing energy from stored reservoirs and putting it into the system. So we have emergent systems, but feedbacks, complex feedbacks are the most important ones. And we have been talking about human system feedbacks to the system, or the Earth system. So some people refer to this as the natural human system, but now we are within the natural system, so obviously we are perturbing the natural system. So how do we look at it? There are various metrics one can look at in terms of the processes with which we are making change. The relationship between fertility and Human Development Index for 1980, 2000 and 2014, there are snapshots done every few years by some UN agency, the UN Population Division and so on. So here are children per women or total fertility rate, and you can see the Human Development Index. Obviously higher the index includes per capita income, health, education, and various other metrics that go into it, but not unexpectedly Niger is up here in terms of high fertility. This is a bit old, but still the fertility rates overall have dropped everywhere, but still there are some holdouts which are related to complicated factors. But you can see Central African Republic here, Haiti here, Zambia here, Nepal, Bangladesh, Gabon, and so on, and Argentina here. I can't even read what this one is, but as you can expect, all the rich countries tend to be here: France, Japan, Hong Kong, and so on. Any country that's below 2.1 is below replacement rate, which means each couple has to have on average 2.1 kids to make sure the population doesn't go down. But many countries are below replacement already, and they typically have high HDI or Human Development Index. You can also look at this in terms of environmental footprint. It turns out that higher the HDI, higher the environmental footprint, which means you get quality of life by degrading the environment. Sustainable development means we have to find other ways of doing quality of life without degrading the environment, right? So if you look at the average births per woman as a map, you can see highest here again Niger. This is from Visual Capitalist here. So Africa has high numbers here as expected, some in Asia, and usually have below replacement rates all over the place. So Saudi Arabia is a anomaly because it's a very rich country and pays people to stay at home and do nothing because of the oil money. India is surprisingly just about at replacement rate, but population still grows. China is getting towards darker colors, so it has reached peak population already, and here it's at 1.3. So lowest 10 are here: South Korea, Hong Kong, Puerto Rico, Macau, Singapore, Malta, Ukraine, Spain, Italy, and China. Of course, you have to be careful because these may include immigrations as well, in the sense that immigrant population having a higher fertility rate than the native population, even though you want to be careful what you mean by that. Okay, so fertility rates are dropping, and in the meantime urbanization continues unabated. Top 10 cities of the world in terms of population over time, going from 1500 to 1950. Surprisingly, in 1500 you had Beijing, which still remains fairly populated, but I guess it's not the most populated. But even though this data is a bit old, Tokyo, Japan has a tremendous drop in population. We don't see the number here, but it's well below replacement as well. So you can see just for curiosity, Vijayanagar, which was an empire in India, Cairo, Hangzhou, Tabriz, Constantinople, Gore, Paris, Guangzhou, Nanjing. So these are still big cities. Guangzhou, Nanjing, Beijing. Of course, Shanghai is big now, but if you look at 1800s and look at 2010, Tokyo, Delhi, Mexico City, New York, Sao Paulo, Shanghai, Mumbai, Beijing. It's now down to 8 in 2010. Dhaka and Kolkata. So many cities have grown. But of course, this continues. If you look at share of people living in urban agglomerations of more than 1 million in 2021, that's a fairly recent number. You can see that urbanization is quite rampant. You have more than 60% living here in cities, but that's a bit of a distortion because Australia is quite urbanized on the edges and not many live in the middle where there are deserts. Japan is highly urbanized, and surprisingly Mongolia shows up here. China and India are quite urbanized. Misleading still, because on the east coast you have the most populated cities as we saw here with Beijing, Shanghai, and nothing else shows up, but nonetheless most populated city in China is actually neither Shanghai nor Beijing. It's some other city if I remember right. But anyways, okay, so you get the idea that there are urbanization continues, and we expect that more than 50% of the people will live in urban centers by 2050, and a lot of them will be at the coasts as well. So sea level rise is gonna continue to be a risk for them. More than half of the global population currently lives in urban areas, with that portion of projected to reach two-thirds. So two-thirds will be living in urban areas by 2050. 50% will be living within 50 miles of a coast, according to the UN World Organization Prospects report. So you are here now looking at the growth of urban and rural populations as proportion of total population by region, projected out to 2050 as well. But as I said before, we have to be careful about the population projections. So you have urban and rural. So urban are the darker colors, and above that is the rural, making up 100%, of course. So even Africa, which is at 40% in 2014, is expected to continue. Asia is at 47.5% in 2014, will continue. Europe very high, Latin America very high, North America is at 81.5% urban, and Oceania, which includes Australia and the islands, is at 70.8% and is expected to remain flat because there's not much space to urbanize more. Okay, so you see the distribution, and there are many mega cities with over 10 million population. So you can see mega cities showing up everywhere in China, India, Europe, Japan, Africa, North America, South America, and so on. So we are obviously making huge changes in the land use and climate associated with that. Life expectancy versus GDP per capita. Obviously, this is expected that as GDP goes up, life expectancy goes up, so that's related to Human Development Index, obviously. So life expectancy going from here, very few are below 55 years, so Chad and Nigeria show up here, but this is from 2018. I'm not sure it would change much by 2024 anyways, but you can see here Niger and Democratic Republic of Congo, down here Ethiopia, then you get into the 70s with Tajikistan, North Korea, Vietnam, India, and China is up here at 75 to 80. Japan still lives long, Switzerland, Netherlands, and so on, with increasing per capita GDP. Saudi Arabia, United States, and so on. So not unexpected that healthcare facilities, overall standards of living, and so on are very high in rich countries, so they live longer. But now obviously aging problem that we talked about before is huge for China and Japan, and becoming bigger for many other countries as well. So maybe I'll stop here and read some text on what we mean by these processes, our processes of change, when we start coming back to sustainable development. Okay, see you in the next podcast.